Welcome back, guys. In this video, we are going to be going through section 8.3, which is hypothesis testing, testing a claim about a mean. Remember, the last video was talking about a claim about proportions. Now we are doing means. So part one, we'll deal with the very realistic and commonly used case in which the population standard deviation is not known. And then part two, we will talk very briefly about when the population standard deviation is known, which is very rare. So the objective, use a formal hypothesis test to test a claim about the population mean mu. That's our goal. Notation again is we have n equals the sample size, x bar is our sample mean, the mean of the sample we're looking at, s is the sample standard deviation, and then mu of x is the population mean. Our requirements, the sample is simple random sample, meaning we have good data. 2, either or both of these conditions are satisfied. It either must be normally distributed or n is greater than 30. Again, in section 8.1, we introduced this formula right here to how we get our test statistic for testing a claim about a mean. We have t equals x bar minus mu of x bar divided by s divided by the square root of n. And we can get this by using technology or the formula. So the p-value, use technology or the student t distribution, table 8.3, with degrees of freedom given by degrees of freedom, df, equals 1 or n minus 1. The critical values, we will be using the student t distribution as well with the same rules for degrees of freedom. So the requirements, we just kind of went over this. And then a review from chapter 7. The student t distribution is different for different sample sizes. It has the same general bell-shaped curve as a normal, but its wider shape reflects greater variability. Has a mean of t equals 0. Sample deviation varies. And as the sample size gets larger, it gets closer to a pure normal standard distribution. So let's look at an example. The author obtained times of sleep for randomly selected adult subjects included in a study. Here are the unrounded statistics for the sample. We have n equals 12, so 12 people. X bar equaled 6.8333 repeating. S equaled 1.99240984 hours. That's our sample standard deviation. Okay? A common recommendation is that adults should sleep between 7 and 9 hours. So use the p-value with a 0.05 significance level to test the claim that the mean amount of sleep for adults is less than 7 hours. So of the 12 people, their average was 6.833. And we want to know, can we make a claim that the mean amount of sleep for adults is less than 7 hours? So here are our 12 results right here. And that gives us these sample parameter values. Okay? We have to do a requirement check. It is random. However, n is less than 30. But the distribution of adults who slept is relatively normal, so we will say that it is satisfied. So our claim is that the mean amount of adult sleep is less than 7 hours, so that becomes mu is less than 7. The opposite of that, the complement, the alternative to that, is mu is greater than or equal to 7. Because the statement mu is less than 7 does not contain equality, that becomes the alternative hypothesis. So the null hypothesis, which has to have the equal sign, will say mu equals 7, and then mu is less than 7 is the alternative hypothesis. Again, the alternative hypothesis is the original claim. We will use a significance level of 0.05. And because the claim is made about population mean, the sample statistic most relevant is going to be the sample mean, so we will use a t-distribution. A t-distribution has this formula right here. Plugging in our values, we get a t-value of negative 2.90. You can also get this with using your p-value with using your calculator as well. So how to get the p-value with the TI-84, press stat, go over to tests, hit 2 or hit the down arrow to 2, and then hit enter for t-test. And then for your input, you're going to do stats. Mu naught is 7, x bar is 6.833 repeating, sample standard deviation is 1.99240,984, n equals 12, and our comparison is going to be that we are looking for it to be less than the parameter given of 7. Press enter when calculate is highlighted, and then you should get these values right here. We get a t-value of negative 2.90 when we did it by hand. The calculator gives us about the same value as well. Also will give us our p-value, and it will spit back these values back to us. Okay? You can also do it from a few other different methods, but you'll see that all the values are the same. Your book actually gives you a good description of how to do it using all these different software programs. So again, because p-value is 0.3887, and that is greater than the significance level of 0.05, what happens here? We fail to reject the null hypothesis. So because we fail to reject the null hypothesis, we conclude that there is not sufficient evidence to support the claim that the mean amount of adult sleep is less than 7. We fail to reject it. We're not saying that the null is true. We just fail to reject the null. Okay? The p-value method without any technology. So let's look at this example. Example 1 is a left tail test with statistic of negative 2.90. The sample size is n equals 12, so the number of degrees of freedom would be 12 minus 1, which is 11. Given the significance level of a equals 0.05, we are going to now look at table A3. So we're going to refer to the row of table A3 corresponding to 11 degrees of freedom. And we're going to refer to the column identifying an area one tail of 0.05. The intersection is going to be giving a critical value of 1.796. But this test is left-tailed, so the actual critical value is just going to be the negative of that. So the figure shows that the test statistic is t equals negative 2.90, and that does not fall within the critical region bounded by the critical value. So again, we fail to reject the null hypothesis. Our critical value was negative 1.796. Our sample gave a t-value of negative 0.290. Since that is outside of that green shaded region, we fail to reject the null hypothesis. Next is the confidence interval method. So left tail test, significance level of alpha is 0.05. So we should use a 90% confidence level. When we use the methods we learned previously, the 90% confidence interval is going to give 0.58 hours, which is less than mu, which is the actual population mean, which is less than 7.87. In testing the claim that mu is less than 7, we are using our null hypothesis with the assumed value of x equals 7. And since that is contained within those values, the confidence interval is telling us that 7, it could be a value of mu. We don't have sufficient evidence to reject that claim, so we fail to reject the null hypothesis. So since 7 falls within these ranges, it could fall within that. We're 90% sure that the value could be between those intervals. So we fail to reject the null hypothesis. Last example, is the mean body temperature really 98.6? Now, we've always heard that your thermometer should read 98.6. So let's test that. So data set 3 in your textbook, Appendix B, includes measured body temperatures with these statistics for 12 a.m. on day 2. I don't know. Important thing is that n equaled 106. Your sample mean was 98.2, and your standard deviation was 0.62. So use a 0.05 significance level to test the common belief that the population mean is 98.6. Requirement check is good. So we're saying the claim is that the population mean is 98.6. So mu equals 98.6 when expressed in symbolic form. So then the opposite of that claim would be mu is not 98.6. So the null hypothesis would be mu equals 98.6. And then the alternative hypothesis is that the mean is not 98.6. It is either 98.6 or it's not 98.6. Has to be one of those two things. As specified in the statement of the problem, the significance level is 0.05, so we will be using a t-distribution since we are dealing with population means and sample means. Using the formula, where we can use what we did in the previous examples with technology, we can get t-value is negative 6.64 or negative 6.61, depending on which method you use. All right, the p-value is essentially 0, which is, really, really small number using table A3. If we did the critical value method, we get plus or minus 1.983. Again, it's plus or minus since we're using a not equal symbol. We are interested in both the left and the right tail. And the 95% confidence interval would be 98.08, which is less than mu, which is less than 98.32. So what do those three things tell us? All three approaches lead to the same conclusion. The p-value of essentially 0 is less than the significance level of alpha is 0.05. Okay, the critical value. The test statistic of negative 6.64 falls in the critical region, bounded by negative 1.983. You have your normal distribution. You have a negative 1.983 to the left. This is going to be falling within that left tail region. The claimed, for confidence interval, the claimed mean of 98.6 does not fall within the confidence interval bounded by the upper and lower limits of this right here. So what does all that mean? How do we interpret it? There is sufficient evidence to warrant rejection of the common belief that the population mean is 98.6. And then finally, what if we have our population standard deviation? Well, then we have this formula right here that we will be using. I told you it would be brief.